Hey guys, welcome back to the next video in our stats series. This one's on mean deviation. What's that all about? Let's take a look. So the mean deviation of a distribution represents the average distance of each value in that distribution from the mean. Now remember, the mean of a distribution is just the average. So what do we care about it? Well, look at the two words. Mean is average and deviation means difference. So how far is each value in a set from the mean? That's what we're talking about here. Now with mean deviation, or how far numbers are away from the average, what we're looking for in a small mean deviation score is that the numbers themselves in the distribution are pretty close to the average, meaning the average represents those values pretty well. But a large mean deviation, where the numbers aren't even close to the average, well, that kind of tells us that while the average is accurate, it doesn't represent the values in the distribution well at all. So here's what I mean in an example. If the mean of a distribution is supposed to represent the average value, we could say that sometimes it's a little bit misleading. Take a look at this example of a couple of values where the average is 75, but it really doesn't represent either of the numbers very well at all. Now let me throw in another example here where the mean again is going to be 75, but the values are way closer to it, showing us that the average, that mean of 75, really does represent the values very accurately. So up on top, student A, two scores, 150, the other 100, has an average of 75, didn't ever get close to a 75 on either score. Student B, though, also an average of 75, is scoring right around 75 every time. So when we calculate mean deviation for student A, we're going to get a large one, meaning it's not very accurate when we look at the mean in terms of how does it represent the numbers in the distribution. Whereas when I calculate it for student B, it's going to be a very small mean deviation, telling me that my numbers are not very far away from that average that I got. Now take a look at these two distributions and see if you can tell which one's going to have a larger mean deviation and which one's going to be smaller. Because one of them is going to be pretty accurate, and the other one, even though the average is the same, it's not going to represent the numbers very well at all. So both distributions have a mean of 82, but in the top one, the numbers are really spread out. In the bottom one, the numbers are really close together, and the mean deviation will tell us exactly what we want to know about how close those numbers are to the mean. So let's look at how we calculate mean deviation. Well, first of all, we have to know the mean of the distribution, and that part's easy because we've already learned that in the last video. So once we have the mean of the distribution, what we need to do is take each value from the distribution and subtract it from the mean. So take a look at how I set that up right here. Now notice when I'm subtracting every value from the mean of the distribution, I'm ignoring any negatives. I'm just writing the difference of that number from the mean itself. I don't care if it's above or below. I just want to know how far away from the mean every value is. So now that I have a list of all my differences as positive numbers only, remember, I don't care if I'm above or below the mean, I just want to know how far away. Once I have the list of those numbers as positive values only, I'm going to take the mean of that new list. So all the differences that I just wrote down, I'm going to add them up and divide by the number of values. Watch how that happens. Now notice I added them up and divided by 8 because I had 8 values in the list. And don't ignore the fact that one of those values was 0, but I still added it anyways, even though that doesn't change the outcome, because it's one of the values in the list, it's one of the differences, and it still counts when I'm dividing by the number of differences. Even if the difference is 0, it's still a valid number in my division. Now I'm going to show you another example of mean deviation. Try and follow along and make sure you understand when I take the differences, I don't care if they're positive or negative, I just want to know how far from the mean. And then when I'm adding them all up and dividing by the total number of values, that's the answer I'm looking for mean deviation.
Hey guys, welcome to the instructional video on mean deviation. And mean deviation is a pretty fancy way of saying really we just want to know how far on average each value is away from the mean. In other words, if I get the distance of each of the average of the distance of each of these from the mean. So it's pretty much procedural. There's really only a few steps that we have to follow in order to deal with these numbers. And the first one is really basic. Since we have to know how far away the average is from the mean, we need to know the mean. And so the first thing we're always going to get is that average. So remembering from the average video, all we have to do to calculate the mean or the average is to get the sum. So 2 plus 5 plus 5 plus 8 plus 8 plus 9 plus 12, oops, plus 15. And we're going to take that, and at the very end, we're going to divide that by the number of data points that there are in that set right over here, and we'll get that by counting 1, 2, 3, 4, 5, 6, 7, 8. And so basically, once we add all of these numbers together, there's nothing complicated here. There's no negatives or anything to give us any trouble. I'll do a little bit of a shortcut and cheat on, tell you that I know the answer to that is 64. But when you do it in your calculator, it's very important that you make sure that you hit that equal sign once you've done all the additions before you do that division. 64 divided by 8 will give me 8, as you can see right there. And so I know that the average is now equal to 8. And so since I have to find out the mean of the deviation means how far each one of those away is from that average of 8. And so the next step is really pretty straightforward. What we're going to do is I'm going to make kind of a little chart that reminds me of the steps. So the first step is going to be to write down all of my data points. There are 8 of them here. I'm going to write them all down in sequence, in order from smallest to largest. So bear with me for a second. 2, followed by a 5, followed by another 5, followed by an 8, followed by another 8, a 9, 12, and a 15. And so I've listed each of those from up here, from smallest to largest. And then the next thing to do is to write down the mean. So I calculated that already. So we know it's 8, and I'm just going to take a second and write it next to each of the values that I've already written down. Now, some people say, sir, do I really need to write down that 8 all those times? I know it's the same number. And the truth is no, you don't actually need to write it down every single time, but for our purposes and for making it clear, I've chosen to do that for you. The next thing to write down is the difference. And the difference is really important because that's what's going to give us our deviation. Deviation means how far away something is. And so when we subtract now each of the points from the average, or the average from each of the points, we're going to get how far away they each are from that average. So 2 minus 8 gives me negative 6. 5 minus 8 gives me negative 3. 8 minus 8 gives me 0. Another 0. 9 minus 8 is 1. 12 minus 8 is 4. And 15 minus 8 is 7. And so here we have a list of the differences. The last row, and this is super, super important, is made up of the following 3 words. Absolute value difference. Now, that's really fancy mathematical wording for a very, very simple concept. And I'm going to show you the simple concept here in red just so it pops so you see it. Really, what that says is go ahead and you make sure that every single number in that list is a positive number. And the reason is we don't care whether the 2 is 6 below 8 or 6 above 8. We just want to know how far away, how many spaces are between the 2 and the 8. And the answer is 6. We know it's 2, that 2 is smaller than 8, so 2 minus 8 is negative 6. But when we're calculating the mean deviation, we want that 6 to be a positive. All the numbers, in fact, must be positive numbers. So the last stage is to change those 3 negatives into positive. Now the ones that are zeros obviously stay 0. And the ones that are already positive stay positive. So really, all this last row is taking all these differences and making sure they're all positive numbers. And the reason, in case you're curious, is because we want to know on average how far away each of them is from the mean, but we don't care whether they're bigger, like this 15 is 7 more than 8, or this 2 is 6 smaller than the 8. We just need to know it's 6 away. Okay, so we ditched those negative signs. And the last step now is to do the actual mean deviation. Remember, we're trying to calculate the deviation, the average of those deviations. So there's a special symbol for that, but you're going to recognize it. And it looks like this. It's got that symbol for average, but we put a little capital D down there in the bottom corner, and that means deviation. So we're going to get the mean of these deviations. The deviations are right here. It was that last step in the 4-step process, and so all we have to do now is calculate the average of this last column. So that's going to be a 6 plus a 3 plus a 3 plus a 0 plus a 0 plus a 1 plus a 4 plus a 7. And we're going to get that sum, and we're going to divide it by the number of elements that are in the set, because it is an average. 1, 2, 3, 4, 5, 6, 7, 8. Right? We're dealing with 8 numbers still, and that will produce for us our mean deviation. Now, very careful, over on the calculator, 6 plus 3 more, plus 0 plus 0. I know adding 0 doesn't change anything on the top of the fraction, plus 1 plus 4 plus 7 gives me 24. Don't forget, I had to hit that equal sign to make the calculator tell me the top of the fraction, 24. And now I can take that 24 and divide it by 8. And I'm going to get 3. And so the answer for the mean deviation is equal to 3. Just quickly, the last thing I want to remind you, very important, about those zeros, that they count as part of that 8. You have to make sure that even though we know they don't change, 6 plus 3 plus 3 plus 1 plus 4 plus 7 is the 24. Adding the 2 zeros doesn't change that 24, but when we do the division, they still counted in the average. They counted in the mean of those deviations, these being the deviations right here. And that's the way it works. So really, just to recap, you get the average, then you list out all your data points, you list out that average next to each data point, you subtract each pair all the way down, change them all to positive numbers, and once you've done that, you go ahead and you get the mean deviation of that last set by calculating the average of those numbers. And that's mean deviation number 1. We'll take a look at mean deviation number 2 in 2 seconds. Hey guys, welcome to mean deviation number 2. The number of students in several classrooms was counted. Calculate the mean deviation. So there's that keyword for us right there, mean deviation of students per classroom. So we want to know on average how far away each of these numbers is from the average of the distances from the mean. So straight up, step number 1 is going to be very simple. If we want to know how far away on average they are from the mean, we need to know the mean. And the mean is basically just the average of these 1, 2, 3, 4, 5, 6 numbers. So that's going to be 18 plus 22 plus 28 plus 32 plus 36 plus 36 and now remember, very important, equals, and that's going to give me 172 for the top part of that fraction. Bottom part of that fraction is a 6. So we can take that number of 172 now and divide it by 6, which is going to give me 28.6 mean average mean. Let's keep that to 2 decimal places. And we'll round it off there at 2 decimal places. Okay, so the next step really is to say, okay, well, how far away are each of these from that mean? So we're going to list out all of our data. So we have an 18, followed by a 22, 28, 32, and then the number 36 2 times. And we're going to write that average, 28.67. Next to each one of those. Yes, I know it's a little bit tedious, but you know what it really does nicely is it shows you each of those subtractions that you're going to have to do next. Because the next step is to get the differences. Since we're looking for the deviation, right? We're going to get those differences, how far each one is away from that mean right there. So that's going to require the use of our calculator a little bit. We're going to go 18 minus 28.67, and it's going to give me negative 10.67. Clear that up. I'm going to go 22 minus 28.67, and for that one we're going to get negative 6.67. And 28 minus 28.67 gives me negative 0.67. Now I'm going to go 32 minus 28.67, and now you should start to see some positive numbers because these are bigger than the mean. 32 minus 28.67 is going to give me 3.33. If I round to 2 decimals, and 36 minus 28.67 is going to give me 7.33. And then 36 minus 28.67, and that's going to give me 7.33 again. So those are our differences, and we know that we're going to have to get an average of those differences, but I'm going to remind you that that last step, very important. It's absolutely vital that you do the absolute value difference. In other words, make sure they're all positive numbers. So 10.60, oops, broke a pencil there, 10.67, positive 6.67, positive 0.67, and then these are already positives, 3.33, 7.33, and 7.33 once again. So the last step, or the last thing to do once we've got all those differences, is we're going to take this list of numbers and we are going to calculate the mean deviation, that being the symbol for mean deviation. So, really simple, average of those numbers. So we're going to start off with the symbol. I'm a fan of the symbol, so mean deviation will be equal to 10.67 plus 6.67 plus 0.67 plus 3.33 plus 7.33 plus 7.33, and once I've got all of those numbers, I'm going to divide by 1, 2, 3, 4, 5, 6. So bear with me for a second. We'll come over to the calculator and we're going to go 10.67 and we'll add that to 6.67 plus 0.67 plus 3.33 plus 7.33 plus 7.33. Please make sure that you do not hit divide yet, okay? Hit that equals. We got a nice clean number, 36 which we are going to divide by 6 to give us a mean deviation of 6. So right there is our average distance from the average, which means on average each of those is 6 away from the average, and that is mean deviation.